Okay, second part of 5-7, we are talking still about Pythagorean theorem. And the converse of Pythagorean theorem says if I give you three side lengths of a triangle, and we know that the two legs squared together added up will equal the hypotenuse squared, then we know it's going to be a right triangle. So converse means, remember, we're just flipping the conditional statement. So sorry. So Pythagorean theorem says if you have a right triangle, then the side lengths added up, or the legs squared and added up, will equal the hypotenuse squared. So the converse just flips it. If a squared plus b squared works, then we know it's going to be a right triangle. And if we don't have a right triangle, we can still use Pythagorean theorem to tell what type of triangle it's going to be. If we have a squared plus b squared equals c squared, it's going to always be a right triangle. Now, let's say c squared is longer than a squared plus b squared. Well, if you look at it as a picture, it's always going to be an obtuse triangle. So we're still going to do a squared plus b squared equals c squared. And if c squared is bigger, if it's a larger number, it tells us that it's not a right triangle, but it is an obtuse triangle. Similarly, if c squared is smaller or less than a squared plus b squared, it's going to be an acute little triangle. And this picture shows why. We haven't talked about the hinge theorem, but we did talk about inequalities in triangles. And if two side lengths are the same, so let's say A and B in all of these pictures have not changed. Let's say A is 3 and B is 4, and here C is 5. Let's say here A is still 3 and B is still 4. Let's say C this time happens to be 6, okay? And same here. We have 3, 4, and let's say we have like 4.5. Okay. Or we could have 4. Let's just have 4. Okay. If you look at this, if we talk about two triangles and two of the side lengths are the same, remember we said if one side length is larger, it's going to be across from a bigger angle. So since 6 is bigger than 4, this is going to be a bigger angle than what's across from 4. Again, just letting you know that if c squared is bigger, it's going to be obtuse. If c squared is smaller, it's going to be acute. So let's see what that looks like in terms of what you'll see in the book. So they're going to give you 3 measures of triangles. It says, first of all, can it be a triangle? If so, classify as acute, obtuse, or right. So remember, the triangle inequality theorem says that if you take the two smaller sides and add them up, they have to be bigger than the third side. If not, if you cut them into squares or cut the straws, you're not going to make a triangle. So 5 plus 7 is bigger than 10. Yes, it will be a triangle. Now, what type of triangle is it going to be? 5 squared plus 7 squared equals 10 squared, maybe. Okay, so 5 squared is 25, 7 squared is 49. We know, I'm putting a question mark because I don't know if it's equal to each other or not. 25 plus 49 is not bigger than 100, it's 74. So in this case, C is bigger. That means it's going to be obtuse. All right, so this is an obtuse triangle. So let's see about this one. 5 plus 8, is that bigger than 17? No, 13 is not bigger than 17. That means if you cut it out with straws, you would not make a triangle ever, 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 ever. So this one, it's not even a triangle to begin with. Now let's try the last one. 3.8 squared. Oh, sorry. Check to see if it's a triangle. 3.8 plus 4.1, is it going to be bigger than 5.2? Yes, so we know it's a triangle. Now 3.8 squared plus 4.1 squared, is that equal to 5.2 squared? If it is, then it's a right triangle, right? So 3.8 squared is 14.44. 4.1 squared is 17.81. And is that equal to 5.2 squared, which is 27.04? So add up 14.44 and 16.81. It's going to be bigger than the 27.01. It's 31.25. My bad. So that the a squared plus b squared is bigger than the c squared. The c squared is smaller. So since it's smaller, then we're going to have an acute triangle. All right, so here's an example of a cute triangle, here's an example of an obtuse triangle, and here's an example of a no triangle that you can never ever make. All right, so that's how we can use Pythagorean's theorem to classify types of triangles. And I think that is the last thing that you're going to be doing tonight on your homework. Let me give you one word problem, because you guys know you just can't go to sleep without a word problem. Okay, so Randy is building a rectangular picture frame. Boom. Done. Okay, he wants the ratio of the length to width to be 3:1. So the length is going to be larger than the width. So I'm going to say that this is the length, and it's going to be 3 times larger than the width. So this is the width. This is the length. Okay, and we know it has to be bigger. And since the diagonal is going to be 12 centimeters. So it's a rectangle, we know this is a right angle, and we can use Pythagorean's theorem to figure out how wide the frame should be. So we have w squared plus 3w squared equals 12 squared. Notice I put the parentheses. You're going to get it wrong if you don't put the parentheses, because 3w squared is really going to be 9w squared. Most people think that that's just going to be 3w squared. Wrong. And then you add them up. 1 plus 9 is 10w squared. Divide by 10, and you get w squared equals 14.4, and then you square root that sucker, and we get about that the width should be about let's see, to the nearest tenth, 3.8 centimeters wide. Done. All right, have fun with Pythagorean's theorem today. Yay.